Hi, my name is Pawan, and I'll be talking about CPU side channels and the channels, the MIDI challenges that we face here. Sorry, I'm still sleepy. I'm in US time zone. Um, okay, so who am I? So I am a Linux kernel engineer at Intel. In the past, I've contributed to mitigations for BHI, TAA, RTS, Red Bleed, MMIO, and a few more. Okay, so quickly going on to the main agenda. So why we are here I'm talking here is because I wanted to present what are the challenges that I face, like I'm currently facing on mitigating these CPU side channels. So the first one is um, sorry. The first one is um, the trusted workloads. They do pay the penalty of uh, due to these mitigations. While I'm sorry, can we switch to uh, second one? I'll be back.
Press down
Um,
at the bottom to move back and forth. Oh, oh, I'm sorry. Okay, sure. I was not quite grabbing there. Okay, let's go ahead and do that. Um, we could. I'm all ready to go, and I'm ready to get mine out of the way, so we can just do that out of order. I'm going to take. Let's see.
Hello, everyone. So continuing from where I left, um, so currently the CPU mitigations, they are applied system-wide, and they affect both the trusted and untrusted applications. And for the cases where it is possible to know whether an application is trusted or not, we have an opportunity to optimize and skip the mitigations on per process basis. An admin can inform the kernel about whether an application is trusted or not, and kernel can choose to skip the mitigations for that app. Um, this mainly requires two changes in the kernel. Um, One would be a separate entry and exit path, or if there are other mitigation points, then we need to have separate paths for those as well. And the second change would be an interface to communicate that change, communicate the trust to the kernel. And that has to be done by an admin user uh, who knows about their system and the workload, if they're trusted or not. For example, like if I've written an application myself, I know I am not trying to attack the kernel, and I would not want that application to have performance loss uh, because it's not untrusted. Um, so for that, I sent a RFC yesterday that does the selective mitigation. Um, so it skips the mitigations for the trusted applications, and there are separate entry and exit paths for uh, the system call. Um, yeah, so it uses C groups to convey the trust level of an application. So there is a new attribute that was added in the C groups. It's called CPU.skip mitigation. And if an admin thinks that, okay, this application is trusted, so it just puts it in a C group and then sets this attribute.
Excuse me. Question from the room. So, trusted, untrusted isn't in the confidential computing sense, right? Because I think that was confusing to me earlier. So,
It
can
is.
you?
It is not in that like confidential computing sense, but then this can be um,
Is there a
extended,
chance to change the
and
name?
then they could,
I think this was
yeah, right. We can change it.
yeah. Names are not important here. Concept is. Go ahead and keep going.
Yeah, so there can be a user space trust authority, like which knows that probably by verifying the signatures or something like that, and then um, puts that application in that C group. Um, this can be manually done as well by an admin, or this can be automated as well. If the user space has confidence that, okay, so this application is trusted. Um, and this can be done using LSMs or any other uh, uh, like X address or any other way of communicating trust. I chose to do it with C groups because it gives us the inherent benefit of using core scheduling. And what that brings is um, the trusted and untrusted processes, they can run on separate cores. So, so like we are already separating the untrusted application to a separate core. So, and we're doing the mitigations for them. And the trusted applications can run on a separate course, and they have a benefit that there is no untrusted process running on the same core at the same time. So this basically enhances a little bit security as well. The other benefit of using C groups and core scheduling is that we don't have to switch between trusted and untrusted apps if you use core scheduling. If the core already has all the trusted applications, we don't have to write the MSR to switch the entry points or make any other changes.
Question, is this specifically for the kernel trusting user space and not wanting to deploy mitigations against user space attacks, or are you also looking at user space to user space?
Uh, Currently, it is only the about like user space attacking the kernel and kernel trying to protect itself. I haven't thought about extending it to user space to user space. I think that should be the next step, but I don't know like how is that possible. Um, Maybe it is. Um, yeah, we can surely talk about that on LKML. But yeah, that's the next possible change that we can do.
But don't you have to consider that in the initial design? Because if you say two things are trusted, but they are not trusting of each other, you have to mitigate against switching from A to B, but not necessarily A into the kernel and B into the kernel.
That makes sense, yes. So if an application is trusted not to attack the kernel, it should be trusted to not attack the other user as well.
That
Because if
does
it
not hold true.
is
Because you could have no secrets in the
it?
kernel and you don't care if the kernel gets attacked, but you may have secrets
But then,
in the user space, and so there are different boundaries there.
Yeah, I do think it's arguable. So I think certainly we could think of this skip mitigations as being something that happens for potentially every vulnerability or potentially every class of vulnerabilities, like we talked about earlier. So I think of this less as like the mechanism and more like the question here is more. Would we like to be able to do this in a group of processes? If we're going to group them, is C groups the right mechanism to group them? Like, does that sound like the right place that people would want this done, rather than like, would we want an all on or all off kind of switch? Because I think you're exactly right. We can't do this in a all the mitigations are on or all the mitigations are off for the C group. It probably isn't fine-grained enough.
Yeah, and I guess what I'm pointing out is if you try and do it in C groups, you don't allow the user space application to express its desires. And you also, and it bleeds in because if you disable everything because you trust the user spaces, then they may be implicit relying on those mitigations to protect themselves.
Oh, you're thinking the problem would be like if you turned off the mitigations in C groups, and then the application expressed a desire with one of the explicit ABIs to go turn the mitigations back on, that there would be a conflict?
Or the user space was just expecting that it would benefit from the mitigations the kernel deployed to protect it against other user space applications running on the same core. Or because then you also have policy built into if you switch applications on a core, if you're doing SMT sibling scheduling, then you would have to have a policy to then turn off to do mitigation. Like I think you have to consider everything before you deploy one part of it. Otherwise, you're going to have whack-a-mole and just a spaghetti.
Right, so if a user space application can compromise kernel, isn't it like it can compromise the whole system? So that makes me think that if an application is trusted to not attack the kernel, it is safe for the entire system. That would be my thinking, but I could be wrong. Yeah. So, any thoughts on what else we can use instead of C groups that would be a better choice?
No. I'm just saying think about the user space desires too, not just the kernel desires.
Okay. All right.
Yeah, I mean, it is a good point. Like, what would you? You're right. Is this protection like? Let's say you turned it off. Let's say you turned it on, or I'm sorry. Let's say you turned the mitigations and you said skip mitigations in the C group. Do you skip mitigations among user to user in that C group? Do you do it across? Yeah, lots of questions there. Yeah, that's a good point. Because you could say, is it skipping mitigations just among, like, keeping it from attacking itself, or worried about attacking another C group, for example? Go ahead, Pawan, keep going.
So
About 5 more minutes.
that's actually the main thing that I want to get the feedback on. The other thing are less important, but then I should still go through them. So for a normal user who doesn't understand these vulnerabilities and mitigations, it's hard for them to decide whether to keep the mitigations on or off. So currently what we have is these two options. Either we can turn off globally, or we can turn on and take the performance hit. Sure, we do have option to turn each mitigation on and off, but then a user who doesn't know about those vulnerabilities is not in the right position to take that decision. So what we can do about it, yeah.
I was just going to ask another question. This is maybe a little bit different, but it looked like in the RFC you posted, you were focused on the syscall entry path. Have you thought at all about how this can be done for like return thunks or indirect thunks? Because there's a lot of performance there.
Correct, but then it involves like patching the kernel. Like if you want to replace the return thunks, it has to replace all the return thunks in the entire kernel. That's a costly operation, and we don't want to do it on every context switch.
I think there are other ways.
They were not.
Yeah, I think there might be other things you can do, although they involve some nasty page table stuff. But I would strongly encourage you to think about it, because I think otherwise this isn't going to provide enough value, at least on certain architectures.
So I think you're saying the stuff that we patch in at boot time is where you feel like a bunch of the problems will be, and we can't turn them off easily once we've committed to them, as it stands.
Yeah, but you don't want to use like SafeRed. You don't want to use SafeRed if you don't have to.
Sorry.
I mean,
what was
there
that?
might be something you can split the kernel page table, and then you can have a special page that has stuff that's different for the two, which sounds super easy.
So have two copies of all the sites that you want to patch, and then switch between those.
Yeah, this is Peter's smiling in the room. We've talked about some things like this, but yeah, it would not be trivial, and it would be not fun. I think Linus has voiced his violent dislike for those concepts.
So if we were to have, say, separate kernel and user page tables, this would be feasible, but nah.
Yeah, so Peter is suggesting what kind of hardware change might be required to make this easier to do in software. As everyone looks at the hardware vendors in the room.
All right. I don't know, like if we can do anything in the hardware.
I have
to go back to the CPU architects.
a question for maybe I can also start a nice fight before the beer time comes. So going back to the question of like what the alternatives to C groups, I think Google's kernel has wonderful hacks for like communicating trust, and I think they include PR, CTL, clone flags, and procfs file systems. And I'm interested, I don't really have an opinion on this, but maybe I'm saying that maybe I provoke someone to express some opinions.
So the policy has to be embedded somewhere, and I think C groups is a good enough abstraction just because it can be done on the command line by systemd or some admin somehow. Going into PRCTL, etc., is just patching a whole bunch of stuff written already. C groups also seems like a reasonable abstraction because within the C group you can have multiple processes and you can say, yeah, all of them trust each other, just disable everything for these.
I'd like to ask, are the mitigations required if the user is only user on the machine, but if he runs JavaScript in a web browser?
If a user, okay, so in that case, we don't want to make the browser as a trusted entity because it can run an untrusted code. So anything that can run an untrusted code on behalf of an attacker, so that should not be trusted at all.
Yeah, so, and is it possible to set it up so that only the browser gets the mitigations? Such as, for example, the compiler doesn't need to have mitigations because the user is compiling his own code. You put it in a secret. Yeah.
So I don't know if I understood your question correctly. So
the answer to the question
that
is that you have C groups per task, per process, and you would put your browser into a C group that has much more restrictive mitigations than your compiler that's just building the kernel.
Yeah, and the other problem is like interpreters like Python, Perl, they can be trusted, but the code that they run is not, like they could be running an attacker-controlled script that may try to influence the branches in the kernel. So yeah, so anything that can run an untrusted code on somebody else's behalf should not be trusted.
If for say the example of like a Python interpreter, just trying to think where this is most applicable, because if you can potentially run some untrusted code in a Python interpreter, I think these side channels are the least of your worries, right? Yeah.
This is why you should not find bash.
Yeah, sure.
Take, for example, a branch history injection. So branch history injection should be possible with a Python script.
Yeah, I agree, but also, I mean, what would you anything you want to do potentially with the Python script, kind of depending on privileges.
You can't write can't write C group files with branch registry injection, I think is the key link, right?
Oh, I was mainly thinking, well, what if I just steal cookies from your browser database with the Python script? That's probably easier to do and more useful. Yeah. Not hard enough. It doesn't prove anything. That's fair.
Okay, well, I think the questions are wrapping up in the room. Anything on the chat or any last questions in the room? Otherwise, we're getting to the end. Beer. Yeah, Peter's yelling beer. Okay, well, thank you very much for everybody who participated today. All the questions were great. I think it's beer time. Thanks.
Thank you.